Okay guys, now I've decided to make a video on Half-Life because it is one of the more difficult things that people struggle with. I've also had a couple of people just contact me about it. So what we're going to look at here is Half-Life. The main thing, okay, is definitions. A lot of years they always like to add a question, and the question is, what is meant by Half-Life? Now, you've got to make sure you get the wording right. Okay, as you can see, it says the half-life of a radioactive substance is the time taken for the activity of the source to half. Now see this bit here, activity. A lot of people use the wrong word, like radioactivity, all these kind of things. You've got to use the word activity. Now, from the previous PowerPoints, you learned that the activity, remember, of a source is the number of decays per unit of time. Now, the most common one we use is becquerels because that's the number of decays per second, okay? Remember, half-life is a measurement of time, so it means it can be measured in seconds, minutes, years, anything that's a time. Okay, so these are ones that you should have copied. We then have a graph of what activity against time of radioactive material looks like, okay? Now what we notice, and again, we talked about that in the activity PowerPoint, the activity will always drop over time. It will get less as time goes on. Now, it's a completely random process, but what they can do is they can try and work out on average kind of thing what the time would come out as. Okay, from the graph we can work out the time taken for activity to half in value. So we then have a wee kind of worked one here. Okay, so if you look here, if we start off at 40, right, so half of 40 would be 20, and as you can see it was 2 to 4, so therefore it's taking 2 hours for it to half, so that then means the half-life would be 2 hours. Now when we're at 20, to get down to 10, it should take a further 2 hours, so that it's halving every 2 hours. So it means that what it must have started at, this must have been 80, because 2 hours to get down to 40. Okay, and that's just what these wee bits of notes are saying there. It says there, for experimental data, numerous half-lives would be worked out from a graph and an average taken. You wouldn't just take one, okay, because it might not be exact, and you'd maybe get 2 hours and 5 minutes, 2 hours and 10 minutes, 1 hour 50 minutes, but that would average out at about 2 hours, okay? Now, normally when they actually give you questions, you don't usually get it as a graph, okay? The questions usually ask you 4 different things. They either ask you to work out the half-life, the initial or starting activity, what it started at, the final activity, or even sometimes the total time that a source is decaying for. It says for some questions also mention background radiation. Now half-life only applies to the source itself, so the background radiation would need to be subtracted. So what that means is, if I've got a source that's got an activity, round about it, it might have already about 30 becquerels. Now the background activity, because it's constant, it's not going to decrease. So what you'd have to do is take it off of your initial value, then start halving it and then add it back on at the end, because it's still going to be there, okay? And that's, I think, the 4th example. So if we look at example 1, now this is one of the ones that says calculate the source's half-life. So how we have to always start these is, we're starting at 160, we've got to get to 10. Now the way I like to do it is, as you can see, 160, then an arrow 80, arrow 40, arrow 20, arrow 10. Now one of the big things that people make mistakes here is that they basically look and say, okay, 1, 2, 3, 4, 5 numbers, and think that's 5 half-lives. It's not. I prefer that people number the arrows, because it's the number of arrows, because that's the number of times it's actually halved. So when we get that, we get that it is actually been 4 half-lives, okay? So if 4 half-lives are equal to 10 hours, 1 half-life, simple enough, would just do the 10 hours divided by 4, and that would then give us 2.5 hours. And that's our first example on how you would do these ones, is if you're asked to work out what the source's half-life is. Okay, example 2, it says a source has a half-life of 20 hours. After 5 days, it has an activity of 50 becquerels. What was the source's initial activity? Now, because we're trying to work out the initial, rather than halving it, we're going to have to go back the way, so we're going to double it. Okay, so it says if one half-life is 20 hours, how many lots of 20 hours are in 5 days? So what you'd have to do is think how many hours are in 5 days. 5 times 24, so we'd get 120 hours. So if one half-life takes 20 hours, how many 20s are in 120 basically? So we just do 120 divided by 20, and we get that it's going to be 6 half-lives. So now what we're going to do, because we want the initial activity, we're going to start at 50 and we're going to double it 6 times, okay? So we start off 50, double it once, twice, 3 times, 4 times, 5 times, 6 times, and we end up with 3,200 becquerels, and that's our final answer. Now, I've done it working back the way across the page. You could have just done it starting from the left-hand side and do 50 and double it each time. I just prefer to always have the initial at the left-hand side and the final at the right-hand side. Okay, guys, so that's all. It doesn't matter if you've done it the other way around, okay? Got to remember and put the units in, okay? And usually it'll just be the units in the question. Now, this one is becquerels, but a lot of times it might be things like kilobecquerels, megabecquerels, okay? So you've just got to make sure you put the correct unit in, okay? Okay, example 3, a source has a half-life of 12 hours. Its initial activity is 2,000 becquerels. Calculate its activity after 2 days. So again, if one half-life is 12 hours, what I'm wanting to do is I'm wanting to work out, well, how many lots of 12 are in 2 days? Okay, so 2 days would be 48 hours. So therefore, I'll end up with 4 half-lives. So because I want to find the final activity, I'm going to half it 4 times. So I'll start at 2,000, half it once, twice, 3 times, 4 times, and I get the answer 125 becquerels. Now, mistakes that people do is they say, oh, 2,000, 4 half-lives, I'll just divide 2,000 by 4. It's not, you've got to half it 4 times, okay? Now, these types of questions in the actual exam, if you show anywhere in the question that you are halving it, or that you realise you've got to half it in some way, even if you half it wrongly, after that, if you've shown anywhere, you'll get 1 mark. They're usually a 2-mark question, so it's not too bad, okay? The last one here is probably the most difficult ones, okay? And that's because they've added in that it had a background radiation. So this again, it says activity of a source is measured on a GM, which just means Geiger-Müller tube. In the old standard grade, you had to describe what a Geiger-Müller tube was. You don't have to do that in National 5, okay? You just need to know that's what a GM is for, measuring activity of a source. The reading includes a background radiation of 100 becquerels. If the half-life of the source is 3 hours, what will the reading be on the GM tube after 9 hours? It says you can assume the background radiation will stay the same. So there's a couple of things we need to do. First thing is we need to work out how many half-lives there's going to be. Okay, so as I said, we'll start off. First thing we're going to do is get the actual activity. So because it was 1,500, we need to take away the 100, okay? The 100, which was the background, and we'll end up with 1,400 becquerels, okay? We then work out that if one half-life is 3 hours, if we're going to let it run for 9 hours, 9 divided by 3 will just be 3 half-lives. So we start 1,400, half it once is 700, half it twice, 350, half it again, 175 becquerels. Now the problem is a lot of people just finish here, but we've now got to, because it's asked us for the reading, we've got to add the background radiation back on, okay? So the final activity of the source is 175 becquerels, but because we have background round about it, you need to add that back on, so we end up with a final answer of 275 becquerels, okay? Now, I told you to miss this out, so don't worry about it. Just a good funny physics joke, okay? Carbon dating, ho ho ho. So when you look at these ones, explain what is meant by the term half-life. All that's saying is, that definition I gave you on the very first page, what would it be? Okay, write that out again. Okay, it then says the activity of the sample 131 is 56 megabecquerels. How long will it take for the activity to drop to 175? So you'll start at 56 and just half it until you get down to 1.75. You then will look and count the arrows, not the numbers, count the arrows. Whatever that number is, you would then just multiply it by the number of days for its half-life, which is 8.1. Okay? It then says a patient, all you've got to think about is, would you want it to be in your system for a long, long time? It has to be in long enough so that it works, but do you really want it to be in it for 16 million years? If it was in it for 25 minutes, it's going to be over and done with, and you've got to last for several hours, so think about it. Okay? Next one, state what is meant by the activity. So remember, the activity is the number of decays per unit of time. State what is meant by half-life. Again, same as the definition before. Calculate activity of the cesium 150 years after its removal. 30 years, how many 30s go into 150? This is what it started at, and you've got to half it that many times. Okay? And that's the end of it. Any other problems, just give me a wee email. Cheers, guys.